neural networks are secretly shaping your life. Neural networks are one of the cornerstones of artificial intelligence, and their influence is growing exponentially in modern society. These advanced systems, inspired by the structure and function of the human brain, consist of interconnected nodes, or neurons, that process information in layers. Neural networks were conceptualized decades ago, but their real potential has only been unlocked in the past few years due to advances in computing power, algorithms, and the availability of large datasets. Today, neural networks power technologies that we use daily, often without us realizing it. From virtual assistants like Siri and Alexa to complex financial systems that detect fraud in real time, neural networks are integrated into countless applications, silently shaping how we live, work, and interact with technology. This video explores the fascinating world of neural networks and uncovers how they are becoming a driving force behind many aspects of our daily lives. Foundations of neural networks. To understand how neural networks operate, we need to delve into their foundations. Neural networks are mathematical models designed to mimic how the human brain processes information. They consist of three main components. Input layer. This is where the network receives data, such as an image, text, or numerical value. Hidden layers. These are intermediate layers where the network performs computations. Each neuron in a hidden layer receives signals from previous layers, applies a mathematical function, and sends the result forward. Output layer. This is where the network delivers a final prediction or classification, such as identifying an object in an image or translating a sentence. Each connection between neurons is assigned a weight, which determines how much influence one neuron has on another. During training, these weights are adjusted through a process called backpropagation, which minimizes the error in the network's predictions. Neural networks also use activation functions like RealU or sigmoid to introduce nonlinearity, enabling them to learn complex patterns in data. Over time, the network becomes capable of making accurate predictions based on the patterns it has learned, a process that mimics the way humans learn from experience. Training neural networks. Training a neural network is a sophisticated and resource-intensive process. The first step is to collect a high-quality dataset relevant to the task, such as labeled images for object recognition or medical records for disease prediction. The data is then divided into training, validation, and testing sets. During training, the network processes the input data, compares its output to the expected result, and calculates the error. This error is then propagated back through the network using algorithms like gradient descent, which adjusts the weights and biases of the neurons to improve accuracy. The network's ability to learn depends heavily on factors such as the size and quality of the dataset, the architecture of the network, and the choice of hyperparameters like learning rate and batch size. Regularization techniques like dropout are often employed to prevent overfitting, where the network memorizes the training data instead of generalizing to new data. Training large networks, especially deep neural networks with many layers, requires significant computational power, often provided by GPUs or TPUs. Once trained, the network is validated and tested to ensure its accuracy and reliability before being deployed in real-world applications. Neural networks in everyday applications. Neural networks have infiltrated many aspects of daily life, often in ways that go unnoticed. For instance, recommendation systems on platforms like Netflix, YouTube, and Spotify rely on neural networks to analyze your preferences and predict content you might enjoy. In e-commerce, platforms like Amazon use neural networks to provide personalized shopping experiences by analyzing purchasing behavior and suggesting products. Another critical application is in the realm of natural language processing, NLP. Virtual assistants such as Siri, Google Assistant, and Alexa use neural networks to understand spoken commands, process natural language, and deliver accurate responses. Similarly, neural networks power real-time translation tools, enabling seamless communication across different languages. In healthcare, neural networks are revolutionizing diagnostics by analyzing medical images, detecting diseases like cancer, and predicting patient outcomes. Self-driving cars also rely heavily on neural networks to process visual data, interpret their surroundings, and make real-time decisions. These examples demonstrate how neural networks have become an indispensable part of our everyday lives, silently enhancing convenience and efficiency. Neural networks in creativity and art. Beyond traditional applications, neural networks are playing a transformative role in creative industries. Generative adversarial networks, GANs, a specialized type of neural network, are capable of creating stunningly realistic images, videos, and even music. AI-generated art has become a new frontier, with algorithms producing works that challenge our understanding of creativity. Platforms like DALL-E and Midjourney use neural networks to generate artwork based on textual descriptions, enabling anyone to create complex visual compositions. In music, neural networks like OpenAI's MuseNet can compose pieces in various styles, from classical symphonies to modern pop. Filmmakers are leveraging neural networks to create realistic special effects, while writers are using tools like ChatGPT to generate scripts and novels. This democratization of creativity has opened new possibilities for artists, but it also raises questions about authorship and the role of human intuition in art. Neural networks are not just tools, they are becoming collaborators in the creative process. Ethical implications of neural networks. While the benefits of neural networks are undeniable, their rapid adoption raises significant ethical and societal concerns. One major issue is data privacy. Neural networks require vast amounts of data for training, often collected from users without explicit consent. This data can include sensitive information, posing risks if it is mishandled or used for surveillance. Bias in neural networks is another critical concern. If the training data contains biases, whether related to race, gender, or socioeconomic status, the network can perpetuate or even amplify these biases in its predictions. For example, biased algorithms in hiring processes or loan approvals can lead to discriminatory practices. The potential misuse of neural networks in creating deepfakes is another pressing issue. By manipulating audio and video, deepfake technology can spread misinformation or damage reputations. Addressing these challenges requires robust regulatory frameworks, ethical AI guidelines, and transparent development practices to ensure that neural networks are used responsibly. Neural networks in scientific research. Neural networks are revolutionizing scientific research by accelerating discoveries in various fields. In genomics, they are helping researchers analyze massive data sets to identify genetic markers linked to diseases, paving the way for precision medicine. Neural networks are also transforming drug discovery by predicting how different compounds interact with biological systems, reducing the time and cost associated with developing new treatments. In astrophysics, neural networks analyze data from telescopes to identify exoplanets, study cosmic phenomena, and even detect gravitational waves. Climate science also benefits from neural networks, which enhance weather prediction models, monitor environmental changes, and simulate the long-term effects of climate change. These advancements are not just speeding up research, but also enabling discoveries that were previously impossible due to the complexity of the data. The role of neural networks in security. Neural networks are playing a critical role in enhancing digital and physical security. In cybersecurity, they are used to detect and prevent cyber attacks by analyzing patterns of network traffic to identify anomalies. Intrusion detection systems powered by neural networks can recognize suspicious activities in real time, offering robust protection against malware, phishing, and ransomware attacks. In physical security, neural networks are used for facial recognition systems, enabling secure access control in workplaces, airports, and even personal devices. Neural networks also enhance surveillance systems by identifying unusual behavior or objects in real time, which is particularly useful in public safety applications. However, the use of neural networks in surveillance has sparked debates about privacy and the potential for misuse in authoritarian regimes. Balancing security with ethical considerations remains a key challenge. Neural networks and the future of work. The integration of neural networks into industries is reshaping the job market, automating repetitive tasks, and creating opportunities for innovation. Neural networks are replacing manual processes in areas like manufacturing, data entry, and customer service, leading to increased efficiency, but also raising concerns about job displacement. For example, chatbots powered by neural networks are handling customer queries, reducing the need for human agents. However, the rise of neural networks is also creating new roles in AI development, data science, and machine learning engineering. Professionals skilled in designing, training, and maintaining neural networks are in high demand. Moreover, neural networks are empowering individuals to upskill and adapt to the changing job market by providing personalized learning experiences through AI-driven platforms. The future of work will likely involve a symbiotic relationship between humans and AI, where neural networks handle repetitive tasks while humans focus on creativity, problem solving, and strategic decision-making. Neural networks and autonomous systems. Neural networks are the backbone of autonomous systems, enabling machines to perceive, reason, and act independently. In autonomous vehicles, neural networks process data from sensors such as cameras, LiDAR, and radar to identify obstacles, predict traffic patterns, and make real-time driving decisions. This technology is revolutionizing transportation by improving safety, reducing traffic congestion, and lowering emissions. Beyond transportation, neural networks are driving innovation in robotics. Autonomous drones equipped with neural networks can perform tasks like surveying disaster zones, delivering goods, and even assisting in agriculture by monitoring crops. In manufacturing, neural networks enable robots to adapt to new tasks and environments, making production lines more flexible and efficient. The increasing sophistication of neural networks in autonomous systems promises a future where machines collaborate seamlessly with humans, but it also raises questions about regulation, safety, and accountability. Ethical challenges of neural networks. While neural networks are transforming our world, they also present significant ethical challenges that must be addressed. One major concern is bias in neural network algorithms, which can result in unfair treatment in areas like hiring, lending, and law enforcement. These biases often stem from the data used to train the networks, which may reflect existing societal inequalities. Addressing this issue requires rigorous testing, diverse data sets, and transparent algorithm design. Another challenge is the misuse of neural networks for harmful purposes. For instance, deepfake technology, powered by neural networks, can create convincing but false images and videos, posing threats to privacy, security, and trust. Additionally, the use of neural networks in surveillance and predictive policing raises concerns about privacy and potential abuse. The ethical development and deployment of neural networks will require collaboration between technologists, policymakers, and ethicists to ensure that these powerful tools are used responsibly. The future of neural networks. The future of neural networks is filled with promise and potential. Researchers are working on developing next-generation neural networks that are more efficient, interpretable, and capable of reasoning. Advances in neuromorphic computing, which mimics the human brain's architecture, aim to create energy-efficient neural networks that can process information more naturally. Neural networks are also expected to play a key role in achieving artificial general intelligence, AGI, where machines can perform any intellectual task that humans can. This milestone, though still years away, could revolutionize industries and solve some of humanity's most complex problems. However, achieving AGI will require breakthroughs in understanding human cognition, as well as careful consideration of the ethical and societal implications. As we move forward, neural networks will continue to shape our world in profound ways. Their impact will be felt in every aspect of our lives, from healthcare and education to security and the economy. Embracing these advancements while addressing the challenges they bring will be key to ensuring a future where neural networks benefit all of humanity. As neural networks continue to shape our lives and drive technological progress, understanding their potential and challenges becomes increasingly important. If you're fascinated by the incredible capabilities of neural networks and want to stay updated on their latest developments, make sure to like this video and share it with others who share your curiosity. Don't forget to subscribe to our channel for more in-depth explorations of cutting-edge technologies and their impact on our world. Hit the notification bell so you never miss a new video, and let us know your thoughts in the comments. What excites you most about the future of neural networks? Your engagement fuels our mission to deliver high-quality, science-based content that empowers and inspires. Stay curious, and we'll see you in the next video.